Welcome to EDU World Space.
The things we know from the problem is that there are two batteries that are connected in series, and each battery is 1.5 volts. And connected to these batteries is a light bulb that has a resistance of 17 ohms. In part A of the problem, we're asked to find what power is delivered to the bulb, assuming that we can neglect the internal resistance of the batteries. So right away, we can use the equation P is equal to V squared over R, since we have actually the EMF of the batteries, and if we ignore the resistance, then this is also the terminal voltage, so we can use it directly in here, and we're given the resistance. So there are two batteries, so that's 2 times 1.5 volts squared over 17 ohms, and the power that's dissipated here, or that's delivered to the bulb, is 0.53 watts. Okay, and now we move on to part B of the problem. And in part B of the problem, we're asked that if the battery lasts for 5 hours, so we have D equal to 5 hours, what is the total energy delivered to the bulb? Okay, so I'm gonna convert this immediately to seconds. So that if we multiply by 60 minutes in 1 hour, and then 60 seconds in 1 minute, this will give us the time in seconds. Right? And then, so I'll just save this part of the computation for last. So we want to know what energy is delivered. So energy is power times time. So we have found the power in part A, and then we have written out the time here in this long expression. So U E, which is the electrical energy delivered to the bulb, is 0.53 watts times 5 times 60 times 60 seconds. And remember that watts is actually joules per second, so the seconds will cancel out, just giving me dimensions of joules, which is the dimension of energy. So when you put all these numbers in your calculator, you find that you have 9,540 joules. And I'd urge you to actually put in the numbers yourself and make sure that I haven't made any mistakes. Okay, and now we're going to move on to part C of the problem. So let's read part C. In part C, it says, the resistance of real batteries increase as they run down. If the initial internal resistance is negligible, what is the combined internal resistance of both batteries when the power to the bulb has decreased to half its initial value? And we are to assume that the resistance of the bulb is constant. So when the power changes, we're going to use the same resistance of the bulb, so that same 17 ohms. Sorry. So let's first compute what half the power is. So we already know that the initial power was 0.53 watts. We calculated that in part A. So half of this is 0.265 watts. Okay, so we have half the power. And the next thing that we're going to do is we want an expression that will include the internal resistance. So again, we can use one main idea is that the total voltage difference around the entire circuit is zero. So we have the battery minus the voltage drop of the appliance minus the voltage drop of the internal resistance, and that's zero. And from here, we can find that the internal resistance is the EMF of the battery here minus the voltage drop associated with the resistor divided by the current. But we don't have the current, so that's something that remains to be found. And what we can do is actually find the current that's associated with this half power, right? So we know that P is equal to I squared times R, right? So we know that R doesn't change when we change the power. So then we can solve this for the current. So then I squared is equal to P over R, or I is the square root of P over R. Okay, so let's put in the values. So at half power we have 0.265 watts, and the resistance is still 17 ohms. That has not changed. So that gives us a current of 0.125 amperes. And now that we have this current, we can find the internal resistance, the combined internal resistance of the two batteries. So R is equal to, well, the total here is 3 volts, right? Because we have two 1.5 volt batteries. So 3 volts minus 0.125 amperes times 17 divided by 0.125 amperes. And once we calculate this, we'll find that the internal resistance is 7 ohms.